Good afternoon. We're on lesson 95 today, and it's going to cover the trapezoidal rule and the error bound for the trapezoidal rule. If you'll look at the bottom of page 486, you'll recall that the way that we find the area of a trapezoid is 1/2 the height times the sum of the two bases. So then looking on page 487, you can see that the trapezoids are sideways. Okay, so the height of the trapezoid is actually this. Okay, so the bases of the trapezoid would be this y0, y1, y2, and y3. The height is along the x-axis. So following along, the initial x is is a, and then x1 is a plus h, x2 is a plus 2h, x3 would be a plus 3h, and so on and so on. The y values would be, this y would be the value of the function evaluated at a. So this would be f of x sub 1, f of x sub 2, f of x sub 3, and so on and so on. So over here, f of b would be this y sub n. Okay, so you can see that from some curves, the trapezoidal rule probably is pretty accurate. It just depends on the curve. If it had any sharp declines, maybe it wouldn't be as accurate. But for what we're going to be doing, you'll see that it is fairly accurate. So using those numbers from up above, here they show us that the exact area of the trapezoid is 1/2 y0 plus y1 times the h plus 1/2 y1 plus y2 times h plus 1/2, and so on and so on and so on. And then remember that the h h is the height, and it's h for all of them. It's that x value, the difference in the x value on the x-axis. So we can factor that out. So it leaves us with y0 plus 2y1 plus 2y2 plus 2y3 and so on, plus yn at the end. So the trapezoidal rule is given at the bottom of the page there. Okay? Thank you. All right, so here's the trapezoidal rule. Pull that in. Right there. All right, so let's look over on page 488. Example 95.1 says, approximate the integral from 1 to 3 of x squared dx using the trapezoidal rule with n equal 4. That means we'll have 4 trapezoids. And compare the estimate to the exact value obtained using the fundamental theorem of calculus. So we're going to use the trapezoidal rule, and then we'll go back and just integrate this and compare the two answers so we can see how close or how far away they are. Okay, so let's just make a table of the x's and the y's. The first x is 1, and the first y would be 1. 1 squared would be 1. Then, and because it's going from 1 to 3, that's 2 units, so the width of each is 1/2. So 1 plus 1/2 would be 3/2. Plus 1/2 would be 2. Plus 1/2 would be 5/2. And plus 1/2 would be 3. Now if we plug this in to x squared, we get 9/4, 4, 25/4, and 9. So we can use that. T will be equal to B minus A. So that's B minus A, 3 minus 1, over 2n. How many trapezoids were there? 4. So 2 times 4. And then times the first y, 1, plus 2 times y1. So 2 times 9/4, plus 2 times 4, plus 2 times 25/4, and then the last one is just by itself. It's not doubled. So that's just using this trapezoidal rule right here. So now if we simplify that, we'll get t equals 2/8, or 1/4. And here we'll have 1 plus 9/2 plus 8 plus 25/2 plus 9. So 1 and 9 is 10, and 8 is 18. Plus 9 plus 25 would be 34/2, which is 17. So it would be 18 and 17 is 35 times 1/4 would be 35/4. All right, so that's using the trapezoidal rule. Now let's go back and evaluate this integral. It would be x cubed over 3, evaluated at 1 from 1 to 3. So that would be 27/3, which is 9, minus 1/3. So that's 27 minus 1 is 26/3. And let's see, if we equate, this is 35/4, and so if we get common denominators of 12, 4 times 6 is 24, that'd be 104. This would be times 3. 105 over 12 and 104 over 12. That's pretty close. That's 1/12 difference. So that's a pretty small difference. Okay, let's go on to 95.2. And this is the integral from 3 pi over 2 to 2 pi. So that's only a difference of pi over 2 here. Cosine x over x dx using the trapezoidal rule with n is equal to 4. All right, so if we're only going from 1.5 to 2, 3/2 to 2, that's only 1/2, and we have to divide it up into 4 pieces. So 1/2 times 1/4 would be 1/8 difference each time. So the first one will be 3 pi over 2. Add 1/8 to it. So that's 12 pi over 8 plus 1 pi over 8 would be 13 pi over 8. Plus 1 pi over 8 would be 14 pi over 8, or 7 pi over 4. And 14 pi over 8 plus 1 would be 15 pi over 8. Plus 1 would be 16 pi over 8, which would be 2 pi. So that's 1, 2, 3, 4, and 2. N equals 4. Oh, because the first trapezoid is between these two, and second one, third one, and then the fourth one. All right, so when we have 4 trapezoids, we actually need 5 x values to determine the areas in between. So now to find this, we have to plug in 3 pi over 2 into this right here. So I'm going to put 3 pi over 2 here so we have it to look at. And that's cosine, comma, sine. So at 3 pi over 2, this would be 0 over 3 pi over 2, which is just 0. And this next one, need a calculator because you have to put in the calculator cosine of 13 pi over 8 and then divide it by 13 pi over 8. So do that and make sure that you're getting this value. These are radian values, so you're going to want to put your calculator in radian mode to do this. So cosine of 7 pi over 4 divided by 7 pi over 4 would be 0.1286. Cosine of 15 pi over 8 divided by 15 pi over 8, 0.1568. And then cosine of 2 pi would be 1 divided by 2 pi, which would be that. So now we just plug it into the trapezoidal rule, which says b minus a over, oops, didn't do that right, 2 pi minus, that was the only thing that needed to be in the fraction, over 2 times the number of trapezoids. So 2 times 4. And then that's multiplied times the first y plus 2 times the second y plus 2 times the third y plus 2 times the fourth y and then plus the last y. All right, so then this is pi over 2 divided by 8 would be pi over 16 times 0 plus 0.15 plus 2 times that is 0.2572, 0.3136, and 0.1592. So the area is 0.1728. All right, that's not too bad. Now, because we know that it's not exact, it would be nice to know what the error is. And if you look on page 489, it shows you that the error has to be less than or equal to b minus a divided by 12 times h squared times the maximum of the absolute value of the second derivative of x. So here the max of the absolute value of second derivative is the maximum value of that second derivative over the interval from a to b. And because h is b minus a over n, the error formula becomes this. The error in the trapezoidal rule will be less than or equal to b minus a to the third over 12n squared times the max of the absolute value of the second derivative. Now, with that, we can find out how much the trapezoidal rule is off from the first fundamental theorem of calculus. So 95.3 says, find the largest possible error of the approximation in example 95.1. So we're going to use this formula. B was 3 in 95.1 and A was 1. So that cubed over 12 times n, there were 4 trapezoids, so 4 squared, times Oh, and it says, oh, f, the second derivative, let's see, f of x is x squared. So f prime is 2x, f double prime is 2. So that's the max, right? There's not depending on anything. So this is just going to be multiplied by 2. So what does that come out to? 3 minus 1 is 2 cubed, which is 8, over 12 times 16, and then times the 2. So 8 times 2 is 16, so we end up with 1/12, which guess what? That's exactly the error that we got in 95.1. We calculated it using the first fundamental theorem of calculus and the trapezoidal rule, and the difference was 1/12. All right, so this formula is very useful. Okay, one more. It says determine the number of subintervals, so that's n, needed to guarantee a trapezoidal rule approximation of 1 to 3 x cubed minus x dx with an error less than 10 to the minus 3. Make a note of that to myself. Okay, we know the formula is this. Okay, so we're looking for n. We don't know n. We know b and we know a. So that's 3 minus 1 cubed over 12n squared. And then, let's see. The first derivative would be f prime of x would be 3x squared minus 1. F double prime of x would be 6x. And if we're talking about from 1 to 3, an interval from 1 to 3, then the max would be equal to 6 times 3, or 18. So this is 18 here. All right, so now let's simplify that. 2 cubed is 8 over, we can take 4 in here, 4 in here, 3 in here. So we end up with error less than or equal to 12 over n squared. Now we know that we want the error, 12 over n squared, to be less than 10 to the negative 3. 10 to the negative 3 is the same as 1 over 1,000. All right, so now cross multiply n squared greater than 12,000. So take the square root of both sides. N has to be greater than the square root of 12,000. And the square root of 12,000 is approximately 109.5445. But we can't divide a curve into fraction of a trapezoid. So we would have to round it up to the next subinterval. So that means that n must have to be equal to 110. All right, so that's it. All for lesson 95. Thank you.